I just wanted to start off the recording so that I don't forget to do it. And I know that for me, I'm definitely going to be returning to the recording of yesterday's session because it was quite a lot. And I have a feeling that this one might also have quite a lot of new information for all of us. So thank you again for joining us. And it's my real pleasure to introduce Dr. Joseph Casillas, who's going to be talking to us today about Git. So I'll tell you a little bit about Joseph, and then I will hand over to him. But Joseph is an assistant professor of Spanish linguistics in the Spanish and Portuguese department at Rutgers. It's incredibly early for him at the moment, so we're very, very grateful that he's doing the session now. I feel incredibly grateful. It's actually afternoon for us rather than 6 a.m. So Joseph's research focuses on second language acquisition and bilingualism. But like all of our speakers in his workshop, he's actually not talking about his core research interest, but his kind of interest and kind of practice in open and reproducible research. So when we looked at Joseph's webpage, we found that he's taught workshops in R, he's written R packages, he has over 70 GitHub repositories, and I recommend also checking out his webpage because his data visualizations are some of the most beautiful ones I've seen. I wish I could do that. So today he's going to talk to us about version control, which I think is really important for any kind of code that we do and maintain, and how to implement version control specifically using a platform like GitHub. And from his abstract, you can see that he kind of thinks of it as a way to also promote both open science, but also collaboration. So over to you, Joseph.
Thank you very much. I will share my screen quickly. I think we're good. Is everyone good? Can you see that okay?
Yep, that's good.
Thumbs up. Awesome. Perfect. Thank you very much for the introduction. Thank you to the organizers for putting this on. I think this is a fantastic idea and something I'm very excited about. I won't say too much about myself because of that wonderful introduction, but I will just leave here my email, the Twitter's there if you're also interested in that. Everything that we're going to do today and everything that we're going to see is on GitHub, ironically. Or not ironically, and as well as the slides. So you have access to all of this. In fact, I should, let me copy and paste this into the chat real quick, just in case. You can follow along. I guess there's a couple of ways you can go about doing this. You could, you can just follow along and watch if you want. You will probably get more out of it if you go through and do the exercises with me. But whatever's fine, this is being recorded, so you can always come back to it. All of that will work. I have been using Git and GitHub for probably close to 10 years. Same with R, and I am very enthusiastic about it. I get excited. Hopefully I don't go fast and talk and get too ahead of myself. But I really enjoy sharing this type of stuff with other people. I think that it's fantastic to improve our workflows. I think we can always try to level up our workflows. And if we can promote open science and reproducible research at the same time, I think that is a win. So with that being said, I'm going to make sure that my questions and stuff here are working. Could you put the first poll on for me?
Yep.
Testing this out to make sure everything works. So we're going to see how familiar the audience is with GitHub to start with. There we go. So on a scale of 0 stars, which would mean no knowledge, oh, mine had stars. I don't know if it's going to say that. 1 in case it doesn't have stars. To 10 stars, expert. How familiar are you with GitHub? So 10 being extremely familiar and 1 being not familiar at all. Got a 10. This is really cool. How many people? There are 35 participants. We've got about 17 responses.
Yeah, I couldn't vote because I'm hosting it, but I probably put myself at 4.
Very cool. But there's definitely a good amount of ones, 33% of the 18 people that have responded with a score, an average score of 3.3. So that's fantastic. You are absolutely 100% in the right place. This is designed for the non-expert and for people that are just getting started. I think one of the major barriers to entry to using Git and GitHub is that the interface that we use is not entirely intuitive. And there's a lot of really specific terminology that is kind of difficult to grasp at first. So I think kind of having the right metaphors and all that will help you out. And that is definitely one of the goals of today, is to get everyone feeling more comfortable with jumping into this for the people that have absolutely no experience. So you're in the right place. You can get 3.2 average, about 25 response. I think that's good enough. I think we'll move on. But thank you very much for your participation. So first question, what are we going to do today? So I have two goals. First and foremost, I want to talk to you about version control and explain why you should care about it. And then I want to get you familiar with Git and GitHub and how you can incorporate these two tools into your workflow to be better researchers. I think that is the ultimate goal here. So what is version control? If you're like me, you probably have had an experience like the one you see in the little comic here on the right, where maybe you finished a document. In this case, it's a Word document, which isn't something we'll work with too much, but you think you're done, and then maybe you get comments from your advisor, and okay, fine, revisions, and then you get it back, and no, final comment, revisions to X, whatever. You get the idea. I think we have all been there. And part of what we will learn today is how to avoid this kind of mess where we have 600 different files that are all keeping track of the same thing. But there's more than that. So I really like some Venn diagrams, I guess not all of them. This one was specifically for data science, but I think that it applies to psychology and probably most fields that do scientific research, where we have to have domain expertise, obviously, in whatever field we study. In my case, linguistics, most people, I don't know, social science, it doesn't really matter. And more we have to know math and statistics to be able to analyze our data, right? And more, we also, it turns out that seems like we have to be computer programmers if we want to use tools like R, for example. And this is also the case with Git and GitHub. So, as academics today, students that are, are in PhD programs right now, you're seeing this more and more. Basically, you have to be able to do a little bit of everything. Here's another one that kind of explains the same thing, right? Where you have to have domain expertise, math and statistics knowledge, but also hacking skills. So part of what we're going to do today with version control is kind of leveling up our hacking skills, even though it's this is going to be kind of like the light version of that. Most of you, I assume, have some type of workflow that deals with this. And if you're involved with R, you've probably seen this infographic before, where somehow you have to import data into some system that you use for analyzing it. You probably have to clean it and tidy it in some way, right? And then you might go through an iterative process of visualizing, modeling, and transforming the data. And then eventually you communicate that to some public. If this is true for you, then you should be using version control, right? You want to keep track of this process. Git is one way to do that. You might have other ways. You probably work with projects for this phase on the left here. You probably have something like this on your computer where you have a bunch of folders, right? For maybe where you store your data, where you have documents, Word documents, or experiment files, or R files, right? You've probably seen something like this. Version control is for you. This whole thing, this whole type of project needs to be version controlled, right? So what is it? Let's give a more formal definition. Recording changes to a file or set of files over time so that you can recall specific versions later. Okay. That's pretty simple. I think most of you with the term version control, you probably have an idea of what that's all about, but it's good to talk about it anyway. I assume that you have probably done this in some way or another in the following way. You have your computer and you have some file that you're working on. In this case, it's called a README file, right? And you deal with some kind of cloud environment, maybe Dropbox or Google Docs, OneDrive. There's tons of them now. You probably use one of those. And the idea is you store a copy of whatever you're working on in the cloud, right? And then you make changes on your computer to this document, and those changes magically appear in the cloud. Or with some of these interfaces, you might even work directly in the cloud and those changes appear on your computer. But in some way, you have this kind of circular process where you're keeping track of things and you're keeping them in sync, right? At the core of Git and GitHub, you're doing the exact same thing, but you actually have to tell the computer to do each step, to send things to the cloud and to bring things back down, which is kind of weird. You might be like, why would I want to do that if I can just use one of these and have it done automatically? And you would be making a really good point if you were thinking that. I would say that the advantages of using Git and GitHub outweigh the inconvenience of learning it at first and doing things manually. And hopefully I'm going to convince you of that as we go along. Though a lot of the major powers behind Git and GitHub kind of come along at later stages as you get more advanced in using it. If you don't do at least this, any type of version control, I tip my hat to you because you are valiant and you like to live life on the edge. But I would definitely recommend doing some type of version control if you do research. Otherwise, you are tempting fate and flirting with disaster. So how do we do version control for reproducible research specifically? Well, today we're going to talk about Git and GitHub, but it's good to know that there are also other ways of doing it, right? There's also platforms like GitLab and Bitbucket that you may have heard of. And essentially they do the same thing. And I'm kind of agnostic to the whole thing. It's kind of like, should I use Python or R for doing statistics? Honestly, I don't think it matters. Do whichever one you prefer, as long as you're doing it. I think then you're kind of on the right path. So today we're going to talk about Git and GitHub. This is the Octocat here that you see on the right. This is kind of like GitHub's mascot, and you're going to see lots of the Octocat in this presentation. So what are you going to need for today? Let's talk. We're going to need three things fundamental. We're going to need Git, an installation of Git on your computer. And I'm hoping that everybody has installed Git already, or that they already had it on their computer to begin with. Most computers nowadays come with it installed. If you do not, you might not be too late. You might be able to jump on this and install it really quickly. And if you have any problems, here's a great website for troubleshooting, but I'm hoping that you have already done this. You also need a GitHub account. This is fantastic. It's free. If you have an academic email, you can have private and unlimited private repositories. There's all kinds of perks that come along with that. If you have not done this part yet, it's not too late. You can still jump on this. You want to give special consideration to what your username is. Kind of an overarching theme of what I'm going to mention today is you want to avoid uncommon characters or spaces. You want to make it shorter rather than longer for reasons I'll explain later. And most people, you don't have to do this, but most people use something that's somehow associated with their real name. So those would be my suggestions, but obviously you are free to do whatever you want. And again, you should have done this already, hopefully. And we also are going to be using GitHub Desktop. This is going to make interacting with Git a lot easier to begin with. In fact, I was explaining just a few minutes ago, this is kind of like having training wheels on your bicycle, which is absolutely fine. This is an easier way to learn. I mentioned before, I've been using Git and GitHub for probably close to 10 years, and I still use something similar to GitHub Desktop. So you can download it for free at this website here. It'll automatically figure out which system you're working on and which version you need to download. So it's pretty easy. And then once you've downloaded it, you can just sign into your GitHub account that you have hopefully already made as well. So that's what we're going to be using, and this is how we're going to move along. So now I want to talk about what is Git exactly. I've been talking about Git and GitHub, and you might be like, okay, yeah, but what is this exactly? How does this work? So let's talk about that. It's actually kind of simple.
Sorry, there's just a question on Slido. I wondered if you just wanted to address
Sure.
it. It's about installation. But Gene asks, I seem to have downloaded both Git Bash and the Git GUI. Does this matter?
No, that's fine. If you have the installation, you should be good to go. We'll keep an eye on that as we go along with some of the exercises. If you have any problems, yeah, obviously ask another question, but it shouldn't matter. Awesome. Any other questions, or is that's it for now? Awesome. Okay, so what is Git? It's an open source version control system. It's extremely powerful. It keeps tracks of changes that you make on your files. And this is interesting, this is important. It keeps track of an entire, what's called a repository or a project. And it just looks at when you make changes to those files. So it takes incremental snapshots, you could say, and keeps track of what changes you make. As I mentioned before, this is conceptually similar to Dropbox or Google Drive or whatever. But as my wife describes it, it's for nerds. And I guess to some degree, she's probably right. The people that really like this kind of stuff might tend to be on the nerdy side. I definitely include myself in that camp. How does it work? As I just said, it keeps track of incremental changes, right? You can think of it as taking pictures of any given project at a certain point in time, and it keeps track of that time. So you can always go back to that point in time. And typically we access Git using the command line. Now, this is where I usually lose people and scare people when I mention the command line. This is something that most normal people don't enjoy working with. So some people do. If you don't know what I'm talking about, then this presentation is certainly for you, but it's when you see something like this where it looks kind of like the Matrix and you have to actually type in what you're doing. Most of you are probably R users as well, so you might not be afraid of the command line. But in any case, this is designed for the people that are afraid of the command line, and then we'll kind of slowly work up to that. So, okay, we know what Git is. What is GitHub, and how are these two things different? That's something that conceptually was very difficult for me to understand at first. And it's actually really simple. GitHub is just an online interface to Git, right? It's a place where you can store repositories of projects. It's like a cloud service, basically, for keeping your projects stored, right? It was purchased by Microsoft, I think maybe like 2 or 3 years ago. It might have been more than that now, which I guess some might consider to be unfortunate, but it doesn't seem to have changed too much. But I do think that's probably important to know. Now, I'm going to give us a quick walkthrough of the interface of actually using Git. At this point, I would recommend also just following along and kind of taking a look at things. But if you want to do it at the same time, that's also fine. So I will switch to my web browser here. I'm hoping you can see this. Actually, I'll probably just make it wider just in case. Just like this. So when I just go to github, of course, my menu bar here is right on top of where I want to put things. Let me move that real quick. All right. So if I just go into github.com, this is the main page that you see. It's a timeline kind of deal like Facebook, which you may or may not like. And you can see the activity of what other people are doing with their GitHub accounts, with their projects. On the left-hand side, right, you have access to repositories that you use often. So these are what are populated on this side. And I will point out this nifty icon in green where it says new. This is something, this icon, you want to kind of be familiar with and keep an eye out for it, because I'll be referring to this a bit. But here's one place where it's at, just so you recognize it. This will allow us to create a new repository very quickly. Another thing I will point out is in the upper right-hand side, you'll see there's a profile icon, and it's a drop-down menu that will take you to a lot of useful places, right? Specifically, I will point out that you can go to your profile from here, and also you can go to your repositories. These are two places that will be useful for us as we move along as well. So I'm going to go to my profile and show you what that looks like. So here's my profile. You can put a picture here if you want. Lots of people do. Mine happens to be the vowel space because it seemed appropriate at the time. If you want, you can kind of put information here about what you do and what you're interested in. Most people just say, you know, where their institution is and maybe their website if they have one. And you'll notice that I also have a tab here that says repositories, and it says 110. I have 110 repositories, which is kind of crazy. Mentioned earlier that I had 70. That's because you only see the public ones. There's also a lot of private repositories as well. So I'm going to click on this tab and give you guys a quick view of what that is like. It's basically just a list of all the repositories that I've created, right? Some of these live on my computer as well. Some of them are only in the cloud. It doesn't really, it's not a big deal. It's just, this is where they live. And as you can see here, there's one at the very top called GitHub Workshop. And this is actually a repository for this workshop today. So I'm just going to open that and we'll take a look. It opens up the project. It gives me a list of all of the files and folders, right? And then there's a README file that has the information about the workshop that you guys probably read at some point before. There's some other interesting tabs for issues and pull requests and actions, and lots of words that we're like, what does this mean right now? And I'll just open up in this index.rmd file, and you'll notice that, oh, it's just a text file, right? Nothing to be afraid of here. And this is actually just the presentation that I'm showing you before. This is the file that creates the presentation, right? Here's my hi with my hand waving emoji that you guys saw at the beginning. And the entire presentation is just a text file, okay? And Git is very, very good at working with text files, right? If you try to use other types of files like Word documents and stuff, it doesn't do as well. But Git is excellent at working with text files. So I think that is everything I want to say about the interface for right now. I'm going to make this a bit smaller and go back to the slides. And let's see, let's review. So we learned Git and GitHub. Quite simple. Git is just a version control system that we're using kind of under the hood that will help us to manage projects and repositories and keep track of changes that we make in these projects or repositories. So GitHub is just a cloud-based hosting service that lets us manage these repositories. So these are how these two things work together. What I will probably end up doing a lot in this presentation is just saying GitHub when I'm referring to both, or just specifically Git. But to me, it's kind of one and the same because I've never really used Git very much without GitHub. That's just how I started. So you might be in a similar situation. And I found this neat infographic that kind of explains the differences. You can come back to this and look if you want. I think the important thing is just notice that GitHub is it's exclusively cloud-based, right? That is kind of the advantage of using GitHub versus just using Git locally on your computer. Awesome. So with that information, we're ready to do our first exercise. Again, I'm assuming that you have Git installed and that you have a GitHub account. All right. Now, this first exercise we're going to do, there's 3 exercises that we're going to do in different ways. This first one, there's going to be a lot of hand holding. I'm going to explain exactly what I'm going to do. And then I'm going to show you in the browser, we're going to do it together. Right. Later on, we'll do the exercises a little bit differently, but this is how the first one is going to go. I'm going to go really slow, and I'm going to try. My aim is to not lose anybody here. There's 36 of us. If I don't lose anybody, that would be incredible. We'll see if that works out. So this is going to be a nice little experiment. So here we go. Our first repo.
Joseph, before we
Yes.
start, I was wondering just if you want to answer Saloni's question in the on Slido about.
Yes, I didn't see it. Please tell me.
Oh, I didn't want to interrupt you now, but I just asked whether you can use GitHub and GitLab at the same time, because I know that some institutions have GitLab, but then you might have your own personal GitHub there.
Yes, that's actually a great question. You can, absolutely. Just like you can use Google Drive and Box at the same time, right? Typically, you won't use both. No, typically, you won't use both on the same project. Like, they don't play well together. They're like cousins that don't get along or something. They do the same thing, right? And you can use whichever one you want with your system, right? But you wouldn't use both of them to track the same project. That makes sense. Yeah, that's actually a great question. Are there any others?
Not
Not for now. Okay. All right, so to the exercise. I'm going to explain exactly what we're going to do in this first step, and then I'm going to switch out of the presentation and do it. So follow along visually, don't do anything yet. So the first thing we're going to do is create a new repository. There's 2 ways that we can do this. Our first option is to click the new icon that you see right here in green, anywhere you see it in the GitHub interface. Okay, that's option A. Option B, if for some reason you can't find that, you can also click on the profile icon that's in the upper right-hand corner, and then scroll down in the drop-down menu to your repositories. And then there you will definitely see the new icon. Okay, so let's just go through this first step and see what that looks like. So I'm in GitHub. Let me go to the main page again. So we should be seeing the same thing. You should be looking at something more or less like this. And I'm going to click on this button right here that says new. Okay. If for whatever reason you don't see that, you could also click on the profile icon, go to your repositories, and then click new. Doesn't matter any way you want. So I'll just click on this since I have it right here. And now I'm going to go back to my slides and we'll go to step 2. So you should be looking at a screen like this. Back to the slides. Step 2, we are going to name our repository. We're going to call it my-repo. And I sound like I'm obsessive. It's not just me. It's good practice. Use the names exactly as I'm giving them to you, because later on, if there's a problem, you're like, oh, well, I put a space there and you did it this way. Well, that might be a reason for errors later on. So try to do these exactly as I do them. And then later on, you can name things however you want. But you'll give the name. You should see a box like this at the top where the arrow is. You'll just call it my repo. And then if you look down a little bit further, you'll see a checkbox that says add a README file. You're going to go ahead and click add a README file as well. And then wait there. Don't do anything else yet. I'll go back into GitHub and I'm going to do exactly that. So right here, I will type my-repo. It tells me that it is available. I do not have this repo on my computer yet, or on my cloud account. I'm going to scroll down, and right here I see add a README file, and I'm going to check this box. Everything else is it.
Sorry,
Yeah,
there's just a comment in the chat, and maybe, I don't know how many people are seeing this, but just to say that I think someone says people who start new don't just have new.
Okay, perfect. Even better. It's even easier. Create repository. Right into it. And that should take you to this same screen. Thank you very much for pointing that out. I haven't seen that with an account with no repositories at all in like 10 years, so I was not aware of that. But that is definitely good to know. So yeah, you should be at the same screen now. And if you're not yet, go ahead and throw another message in there just so everyone knows. In any case, we want to go with this name here and then add a README file. Okay. Step 3. as you might have guessed, we're going to click on the Create Repository button that is at the very bottom of that same page. All right, so here it is for me, Create Repository. I'm going to click this button. And voila. I am now looking at my first repo. We can see the name at the top here, my repo, and it has one file that we see in this little gray box, right? And it says README, all in uppercase, .md. MD, the ending of the file is just Markdown. You may have heard of Markdown files before, you may not have. You'll notice that I can see down here at the bottom, it says README again, and then it says my repo. This is actually giving us a visualization of what that file looks like, even though it's just a text file. And that will lead us into step 4. But actually first, I think we're going to celebrate. I think that was our next plan. Yeah, congratulations. You created your first repo. Hopefully the first of many. I think you have seen that this is actually quite simple. It's not too difficult to create a repo, right? And that's fantastic. We're going to continue, but that was the first step. You made it. Congratulations. Now, what we're going to do now is look in that gray box where you see that readme.md, and we're going to click on that file name. Okay, click on that file name. So I'll go ahead and I'll do that same thing. This is it for me right here. You'll see that it's a link. It turns blue. When I hover over it, I'm going to click on that. Right now, we're just seeing we're inside that file. I guess you could say. Let me come back over here. And step 5 is we're going to click on the pencil icon on the right-hand side. And we're going to edit this file by hand by adding in some text. Okay, so you're looking for the gray pencil icon. And my computer, that is right here. You probably see that right here. Now, when I click this, you'll notice that it just opens up. It's like a text editor in the browser. I can come in here and I can say, hello, this is a fun workshop. And I would encourage you to write anything that you want, hopefully something positive. It doesn't matter, but just put in some text so that the file is changed in some way, okay? After you've done that, you're going to scroll to the bottom of that page, and you'll notice that you have a little some options where you can, it says commit changes, and there's a green button that says commit changes. We are going to commit the changes. So I'm back here, I will scroll down. Here it is for me. It says information, blah, blah, blah. I'm not changing any settings. I'm just gonna click commit changes. There we go. And now you'll notice it takes me back to the root level of my repo. And now I can see the changes that I put in the document, right? It says, hello, this is a fun workshop. So now you should be seeing anything that you typed into that text file when you committed the changes. I'm hoping that is the case for everybody. And that is actually the end of the first exercise. So let's review what we just did, because actually it was pretty easy. I think everyone will agree that that wasn't too difficult, but there are some conceptual ideas that are quite important to grasp. So first thing we did was create a new repository. We saw that there were 2 ways to do that. We gave it a name, probably not a very useful name, but we'll talk about useful names later. And then we added a README file, right? Then we created the repository. We edited the README file by hand. We made some changes to it, and then we committed those changes, right? So you notice I am starting to use kind of specific terminology here. So here are the key ideas. Repositories are just projects, right? Everybody has kind of a conceptual idea. What's a project? Well, in GitHub world, we say repositories. That sound kind of scary, but it's just a project, all right? We commit changes to the repository, and Git keeps track of those changes, okay? We also learned that README files in uppercase letters have special status on GitHub. They're just normal, ordinary text files, but when we see them on GitHub, they appear in the browser, right? And we see them as like a rendered text, I guess you could say. Now, some important tips to keep in mind at this stage in the game is to remember to think carefully about how you name things, right? My experience that 90% of the times, like the first thing that I want to name a file or a project or whatever is almost never the best name. So just calling something like experiment, like later on, you're gonna be like, I have millions of experiments. I don't know what experiment this is. So think carefully about names whenever you're creating repositories and just files in general. And then also, I've mentioned it several times, it's good to avoid spaces and uncommon characters if it is possible. And in many cases, GitHub won't allow you to create a repository if it doesn't like the name that you've used. Okay, so those are the key takeaways. Now, let's see, let me go back to and see if there are any questions.
So there was one that was taken down, so I just want to check. Jean, do you no longer have the question? Because there was one and it just disappeared now.
Okay, then I must have answered the question.
Yeah, no, I figured it out. Sorry.
Oh, perfect, perfect. Do you want to ask it anyway in case someone else might be having that doubt?
I just
No.
missed what the step was right before commit changes, and I figured out that I had to switch to preview first.
Gotcha.
That-
Okay.
Is that right?
Yeah, that sounds right. Awesome. Could we do the second poll? I believe it is.
Is that the one with the confused?
Yes, the confusion poll.
Right.
All right. How confused are you right now? Not at all. A bit, but I'm okay. A bit, and I'm nervous about it. Or where am I? I'm completely confused. I'm totally lost. See how we're doing. Not at all so far with 16 responses. Okay. A bit nervous. A bit nervous is good. A bit nervous is not a problem. We can deal with that. A bit, but okay. All right. This is pretty good. As I mentioned before, the first exercise, I said there's kind of a lot of hand holding, and that was by design, right? To make sure that, that everyone follows along without too much trouble. Let me see if we're doing okay on time. Okay, cool. I think that is enough. I think we can move on. Thank you for the poll. Okay, let's see. So we are going to go on to exercise 2. All right. When I put this picture in the slides, I was thinking clones, right? And then I realized these are just droids and they're actually not clones. I guess they're probably all different individuals underneath the mask. So this probably isn't the best picture, but you're going to remember this now because I gave you this elaborate story. The idea, the concept that we're going to build towards now is cloning. Okay. Now, what we just did, we created a repo in the cloud, right? We have a project in the cloud and we made changes to that. That's fantastic. That's a great thing to be able to do. But most of the time, we are going to work with files on our computers, right? I think that's how probably all of us work. We open a document that we have on our computer and we work with it. So what we need to do at this stage is clone this repo that we created in the cloud, right? And clone it to our computer, right? This doesn't exist on our computer yet. So what we're going to do is clone it and create what we're going to call a local copy, okay? We will refer to the cloud version as origin, right? So that's where it comes from. And then the copy that lives on our computer as the local copy. And this is something that's conceptually kind of weird at first when you first get into Git land, because the idea is that there are different copies living in different places, just kind of like, it's not just the same thing, and it's not. They're two different things and they can be at different stages in their history, I guess you could say. So this is an important concept. Now, think about this. You open a file on your computer, and in a typical day, you probably work on maybe an R script and you're working on your analysis, and then you save it and then you go back to it later and you create some plots, and then you go back to it and you change your analysis because it was wrong and this and that. And you go through a whole series of steps, right? And then maybe at the end of the day, you finish. Like, this is one day's work. Okay, that's fantastic. Now, what we want to do is communicate with the cloud, because the cloud is still back here on this first version, right? And we need to tell Origin about all of these awesome changes that we made, right, over the course of the day, right? So what we're going to do now is commit our changes on our local copy and then push the changes to Origin, okay? So the concepts we've already talked about committing. Now we're introducing pushing, all right? Whenever we talk about pushing, we're talking about moving something from our local copy to Origin. Okay, so that is push. And then if we do it correctly, we have a cloud version, the Origin version, that is up to date and looks just like our local copy. Okay. Again, this is exactly what Dropbox will do for you without thinking. And here we have to do it manually. It's the exact same idea. So local copy and the GitHub copy, right? The Origin copy, they're up to date, right? When they have the exact same history and they're at the same versions of all the files. Okay. I'm going to show you how to do this. So I'm going to actually clone a file, make some changes and push them. I would like you to first just watch me do this, and then we will go to the exercise and I will have you do it with specific instructions. But I think it's handy to see how this works. So I will escape here. I will again remind you, here's my repo. It lives on GitHub in the cloud, right? It's right here. There's nothing too exciting about it. I am going to open GitHub desktop. In my case, I have the dark mode on, so it's black. Yours might look slightly different, but it should be the exact same thing, right? And the first step, if I've signed into my account, is to go File, Clone Repository. I don't know how well you can see that. It might be really small, but there's a file menu at the top. It's a drop down and it gives me the option Clone Repository. So I'm going to click that button and it brings up another window for me. In this window, it says find your or filter your repository. So I'm going to search. Yours probably won't have anything if this is the first time you're using Git, but in my case, there's a lot of things. So I'm going to try to just ignore that. I'm going to type in my -repo. And it says, sorry, I can't find anything. Hang on a second. You're lying. Is that what I called it? Should find it. Did I call it that? My repo on here. How did you find this? Oh, there, never mind. It just took a minute. It was thinking, had to go to space and come back. It popped up here. Here's my username and then my -repo. I got scared for a second. I'm not gonna lie. I was like, why isn't this here? And next, what I'm gonna do is I'm gonna choose where I'm gonna clone this to. And this is something you also want to think a lot about because sometimes you always end up wanting to move projects. I would suggest that for everything that we do today, just put it on your desktop. That way you have access to it right away. So I'm going to choose my desktop. I'll say select, and I'm going to click the button that says clone. Okay, there we go. Cloning, it did some magic in the background. And if I look at my desktop, I actually have to move it because I'm using two screens. There is a folder, which I'm hoping you can see that says my repo. Can everybody see that? I'm assuming you can see that. You have the AutoCAD in the background here. I'm going to open this file. Can I make this bigger? No, I can't do it right here. And I can see here, it's just the README file. What I'm going to do now is I'm going to open this README file. You can just use any text editor. It doesn't matter. It's just a text file. I'm going to specifically, I'll use Sublime Text because that's the text editor that I typically use for everything. And I can see this is just the same file that I saw on GitHub. Let me make this nice and big so everyone can see it. Right? You probably recognize this. My repo, hello, this is a fun workshop, right? Now I'm going to change it. I'm going to say this is not a fun workshop. Cloning is hard. Whatever. I'm going to click save. And I'm going to go back to GitHub desktop. Oh, notice that something changed. I really wish that I could make this bigger. Can I make this? Oh, I can make it bigger. Ah, fantastic. Let me widen this out a bit because I want to point out some things here. You'll notice that it kept track of the change I made. This wasn't here before, and I can see in red where it said, hello, this is a fun workshop. So that was what it was previously. And then I can see in green what the file actually looks like now after I've made the changes. And it tells me specifically what lines were changed, right? And it has the plus sign, meaning that it added lines to it. So now it says, this is not a fun workshop, cloning is hard. Okay, fantastic. It's tracking the change for me. Again, this is the magic that happens under the hood. That's what Git does. It keeps track of the changes. I'm going to go over here to the left-hand side, and I'm going to add in a comment, a useful comment. I'm going to say, showing, cloning, and committing, right? That's in committing, whatever. Oh, I spelled it wrong. I'm really bad at spelling. Is it two T's maybe? Will that make it? Yeah, two T's. Okay. And I'm going to click this button right here that says commit to main. Okay. Now I've committed the changes. That means Git on my computer, on my local copy, it's memory. It's saying, okay, keep this in memory. This is something that has changed, but it's not on the cloud yet. In fact, I'm going to go and show you. If I go back to my repo here, let me just refresh the browser. It still says this is a fun workshop. And clearly this workshop is not fun anymore. The change has not been pushed to the cloud. And that is because we have to make sure we push, right? Right here, there's another button that says push origin, and also up here at the top, push origin. So notice this is a two-step process if we want our changes in the cloud. We have to first commit with a useful message, and then we have to push. So I'm going to click push. Push to origin. It's thinking. It's done thinking. I'm going to go back into the browser, and I'm going to refresh. And there they are, right? This is not a fun workshop. Cloning is hard. Okay? So I've gone through this process of cloning the repo to my computer, a local copy, making changes, editing the file, however, might need to do that, committing those changes with a useful, meaningful message so that I remember later on what I was doing, and then pushing those changes up to the cloud, right? So here they are, and I can actually take a look at this commit history. So right here, it shows the message that I put there. I said showing, cloning, and committing.
Sorry,
Yes.
can I just pause for 1 second, because there are a couple of people on Slido who are kind of saying that on GitHub desktop, they just see the let's get started page.
Okay. I assume that that means that you have not signed into your account yet. Could the people that asked that specific question, if they signed into their account?
They're both anonymous, so I can see that.
Yeah. In any case, you don't have to do that. Oh, I guess we're almost done with the walkthrough anyway, so I guess it is time to try to do that. I would say you have to make sure that you signed into your account first, and then it shouldn't say anything because you don't have any repos yet. You still have to clone. So I'll review that in just 1 second. Was there another question, or was it just that one?
Just that one that needs addressing right now.
Okay. Yeah, we'll come to that in just a second. I just want to point out 2 more things here. So when I'm looking at the copy in the cloud, you'll notice that the commit message is right here. I said showing, cloning, and committing, and I can actually click this and go back and see the changes that I made, right? This is very useful because you can imagine a project that you're working on where you have to go back to a version that you had 6 months earlier because you made a mistake with the participants or whatever. You can find that commit, and then you can actually revert back to how it was before if you need to, right? This is just a handy way of keeping up to date and everything. All right. So that is, I guess we'll say, the end of this little walkthrough. And now we can come back to the actual exercise. Now, what I'm doing here, I'm gonna put the exercise, the steps that you're gonna do on the side, and then I'm gonna open up GitHub Desktop at the same time with the Slido so I can keep track of questions. And I'm gonna ask you to actually go through these steps. So let me just run through them with you to make sure we understand what we're trying to do. So the first thing that you're going to do is clone my repo. Now there's an assumption here that you have GitHub Desktop installed and that you have signed into your account. Signing into your account is the key. Once you have done that, you can look for File, Clone Repository. That's how it is on a Mac. If you have a PC, you might not have the file menu. It might just be GitHub Desktop, and then you click that and it says Clone Repository. I'm not entirely sure. After that, you're going to edit the README file by opening it up with a text editor, any text editor you want. You can even open it in R or RStudio if you would like to. Just make some changes. It doesn't matter what. You're going to save the file, commit the changes with an informative message, and then push the changes from your local copy to origin, right? It'll tell you that it did it, and then go to github.com to see if it worked. Okay, now that's a lot, right? I'm gonna put this here on the side and then make sure that I have Slido here at the same time, and we'll go through any of these questions as they come up while you try to do this exercise. So I'm hoping you can see both of these at the same time. Okay, that person said, it said, let's get started, but they quit the GitHub Desktop and reopened it, and now they can see their repo. Okay, awesome. So you might want to try that, see if that works for you. I think that if you click the update button next to filter your repositories, you will see your exactly. That's exactly what worked for me. Thank you, Sabina. I don't see the cloning and committing option on the cloud. In the cloud. In the cloud.
Sorry, that's me. So I pushed the changes in the desktop, but I can't find them in the cloud now.
Ah, okay. And you refresh the browser and they're not showing up?
Oh, I might not have done that.
Yeah, you definitely have to refresh the browser, otherwise it won't show you. And after you commit, make sure you push. If you still don't see them, if you go back to GitHub Desktop and look and see if you have the option that says push to origin.
Yeah, I did that. I did that already.
So hopefully if you update the browser, refresh the page, you should see it. Okay, let me see what's this. Okay, so everyone had the same thing. As account, yes. Does this mean that all of the versions of the local copy also come to the cloud rather than just the latest version? Exactly, Saloni. So that means that all of the commit history that you have on your local copy is also sent up to the cloud, the entire history, which is a good thing, but also kind of a weird thing. It depends on what the project is. So for example, if you were to go and look at some of my personal projects, you could see my entire commit history. And sometimes I'm troubleshooting something and I'll be like, I just broke this. And like the really weird commit messages. It's kind of embarrassing sometimes, but yes, that is definitely the case. In fact, I think there's a Twitter account that's just some kind of bot that like searches commit histories looking for cuss words. And then it just puts whenever like programmers cuss in their commit messages and it posts it.
I always also wonder about this in terms of like space, like how much space can your GitHub?
Right. That is actually a very, very important question for 2 reasons. So in terms of text files and committing changes, it's actually not a big deal because it's actually a lot easier to keep track of just like changes in a file versus keeping track of multiple files. So in that sense, version control with Git is actually quite efficient. Now, sometimes you might be working with files that are enormous. For example, sometimes I have to work with speech production data where I have large recordings, or some people work with eye tracking data where you have files that have millions of lines. Those can sometimes be problems, and GitHub does have limits for how big a file is that it can track. In those cases, you kind of have to look for some workarounds, but I think the recommended file size should not exceed, I think it's like 50 megabytes or kilobyte. I always get them confused. It's like 50 something. And if you're slightly over, it just gives you a warning. But if you're way over, it'll say, I can't do this, it's too big. So you do have to look out for that. When I try to clone, it states the folder contains files. Git can only clone to empty folders. Okay, so it looks like the place that you've selected to clone the file to is the problem. So I would just click the button where it says it lets you choose where you want to clone to and pick somewhere else. Right, put it in a place that doesn't have maybe another Git repo or that doesn't have any files in it. And I think that should take care of your problem. I have to say this wasn't so bad. Do you think we could repeat the second poll about being confused and see how we're doing? And Shidi, if you have a question.
Yeah, sorry, for some reason as an administrator I couldn't figure out how to post it on Slido. So I just was wondering, you just mentioned the fact that you are that you use not just text files or scripts, but also audio files. So I'm wondering, can it, so if I actually edit audio files, will it
Yes,
track it, and what will it show? Will it actually show like you edited, I don't know, the 500 milliseconds to 550? I mean, what can I see?
No, you won't usually see that. Usually it'll just show that the file changed somehow. I might be able to give you an example of that a little bit later, but it will tell you like the commit message, but you won't be able to see, like, let's say you had a file that was like 10 seconds long and then you trimmed it down to 2 seconds or something. It'll show that the file changed, but it won't show how in those cases. You will only see like very specific differences if you're using text files. Yeah, like you can use like a Word document, which is kind of not recommended, but you can, and it'll keep track of the of changes made to the file overall, like file size, for example, but it won't tell you exactly what changed inside of like the XML. Word documents are just XML code files. It won't tell you those changes.
Oh, okay. So not even Word files. I assume Word files would work like the text. Only in text, it actually shows text.
Exactly. Which is, this is kind of foreshadowing, but this is actually a very good reason for using R Markdown, which we'll talk about on Friday. Yeah.
Thank you.
Yep. Yeah, a great question as well. So let me go back here. I don't know if you guys see this, but we have the poll up again. Oh no, let me talk about the key ideas and then I'll open the poll. So am I sharing my screen? Yes. Okay. So we cloned repositories from origin to our computers and we call these local copies. Fantastic. We work like normal, like we always do on our computer, right? We just type away and change things and write articles or whatever, and then we commit changes, right? Once we finish, we have to push changes from the local copy to origin. Otherwise, the cloud doesn't know about it, right? After we do that, then we can see the changes on GitHub, and it is always a good idea to just check and make sure that you see the new commits that you made. Now, some tips. Always think carefully about where you put your projects, because if you move something and then you open GitHub Desktop, for example, it remembers where it was and then it won't be able to find it. It'll give you a message and say, okay, this isn't here anymore. Do you want to try to find it? Or you can clone it again. There's other, there's workarounds, but it's always a good idea to think about this and plan ahead. I recommend that you practice this procedure that we just did, right? Clone something, edit it, commit, and push. This is what when I do this in class with my students, I make them practice this and do it several times. And at first it's super weird. And then after a while, it's just second nature. You don't even think about it. It's just the way things work, right? You can actually just create dummy repos and just practice with them to get the hang of it. And I think that's a great idea. That's absolutely how I learned how to do it. And then I say, don't be afraid to burn the house down. Sometimes you mess something up, you don't know what you did, you can't remember, it just doesn't work. That's fine. Just delete it and start another one, right? If you have a local copy on your computer, if you're doing this with something that's important, right? That's fine. Make another copy of it and then start over. Right? You can always just, I call it burning down the house and just starting over. It's always a good idea. And I still, to this day, after 10 years or whatnot of using Git, I still have to do that sometimes. So be patient with yourselves. It is a journey. It takes some time, but I think you'll be convinced in the end that it's definitely worth it. Okay, now let's go to the poll that I mentioned before. Let's see. There we go. Not at all, a bit, but okay. Oh, everyone, most people, 14 respondents.
I don't know if you want to answer questions on Slido beforehand, because maybe some people are confused now, but will be less so after you answer the questions.
Yeah, definitely. Definitely. Let's see, can I switch it to the questions? Actually, it won't let me switch it while the poll's running, so next time.
I'll stop the poll for a bit.
Okay, sure.
Is that okay?
Yeah, absolutely. You can turn it back on, I think, maybe afterwards. Yeah, here we go. So how do you sensibly get rid of the practice repos locally and on the cloud? Oh, that's a really good question. So when you're done, like let's say you do all these practice ones, you're like, I don't really need the whole world seeing my practice repos or whatever. I'll show you how you can just go in and delete them. Actually, I'll just do an example real quick. So I'm back in my repo right here. I made my things, and then I decided, you know what? I don't want this anymore. Let me make this a bit wider so you see everything. And you'll notice that on the right-hand side, there's a settings tab. Right, so if I just click settings, I can scroll down to what's called the danger zone, right? Careful, this is the danger zone. That's because things get deleted here, right? Or some changes that aren't reversible. And I can click delete this repository, and then it makes you actually copy in the entire name before it'll allow you to delete it, because it's like, are you really sure? Right, I've put it in exactly as it's called, and now I have the option of deleting the repository, and it really makes sure I understand the consequences of my actions. So you have to make sure you want to delete something. There is also the option of archiving a repository, which takes it out of view, but makes it still exist if you do need to come back to it. I create and delete repositories like crazy, especially for doing workshops and stuff like this for teaching. Like this, my repo, as soon as we're done, I'm just going to delete it. Right? I don't need to have that. Once you've deleted it from the cloud, you can just go back to your desktop, and wherever the folder lives, you can just delete it just like you would normally delete any folder, right? And it's gone, and that's it. That is that. Great question. Maybe a question for later, but why is GitHub better for version control than using Dropbox, for example, in the cloud? Collaboration is easier. I like this question as well, because it's like, this seems like a lot of work. There's like the barrier to entry just for doing the same thing. My argument would be, once you start working more with the R ecosystem is where you really see the benefits of using GitHub, because it's not just, you know, the typical Dropbox type of use where you can just keep track of files. You can also generate web pages. For example, this presentation that you're seeing, which I gave you the URL to, is hosted on my GitHub, and it's just a repo, right? It allows you to do things like that, which make it much easier to, I don't know, give presentations online, create slides for class, that kind of stuff. It also makes it a lot easier. Well, I don't know if a lot easier. It's weird at first, but eventually a lot easier to collaborate with other people that are also using the R ecosystem. So like working with R scripts, it's much easier to keep track of a script when you can actually see line by line changes, right? What else? It's really, there's a lot of benefits for project management, which I'll just show you really quickly, but I hope I have more time to kind of show the benefits of it. I'm going to go into another one of my repos and show you one where I have like a really good example. So let's go to repos. GitHub workshop, GitHub practice, intercultural R&D. Let me search for one that I know has some juicy, actually I can think of a good one. Let me go back here. So here's one right here, learn beef. So this is from another workshop that I was doing previously. You can keep track of what are called issues, right? Where you can just type in something, and I'm going to open this. Stefano, if you're here, I'm sorry that I'm showing your issues to the world, right? And you can just put in a list of maybe things that you have to do on your project, right? And having this inside of your repo is actually a really great place, right? Because it's right there with the code, it's right there with the text and everything you're working on. So maybe we have a checklist of things that we need to do. And if you're working on this with a group of people, they can come through and check things off the checklist. All right, that's cool. There's also what are called projects, which I can't see from here. I have to go back out here, I believe, projects, right? Where you can create, I forget what they're called. They're called like Catan boards or something like that, right? Where you can actually have a list of to-do things, and then you can move them to in progress once you start working on them, and then move them to done once you finish. So here we have done workshop concept, but I could put this in progress, right? And work on it. Right. But then once I finish with it, I can move it over here. So it makes it really easy to manage huge projects with a group of people. right? And you can assign tasks to specific people. So Stefano, for example, is always assigning me tasks. Work on this, change this, do that. No, I'm totally joking. But you can do that in that way. And then it's also controlled. It's version controlled. So you can go back and see, like, hey, I told you on February 24th to do this, and it's July 17, whatever, you know, and it's not done. Like, maybe we can work on that. The power that I really enjoy working on this with my students, because all of my students that are doing their dissertations, for example, their dissertations are repos. Right? So they work on their dissertation, and then they just say, they send me an issue and they tag me and they say, all right, Joseph, I finished chapter 4, take a look. And then I can go in and I can look specifically at what changed in the text file, because it's just an R Markdown document, right? And I can keep track of that. I can make comments, and it's all version controlled, so they can just go back and change things or whatever you want. And it really makes it easy to collaborate with other people. What else? Can we keep local copies on a hard drive, USB key, or would you recommend always on the computer? Yeah, it's not really designed to work on like a USB or a hard drive. I would recommend you keep it always on your computer. If you had a situation where you needed to work on it like on another computer, I'm going to give you a solution to that in just a moment, but that is kind of like the benefit to having it in a GitHub repository in the cloud, that you can access it from anywhere. So we'll show an example of that, I think, in just a couple slides. I think we answered that one. Can we briefly recap exercise 2 on GitHub desktop? Yes, I think that's a good idea, because there were some click here, do this, do that. I'll actually just do it again real quick. And maybe okay, I think we got that. How to push. Okay, so let's just go through some of these questions. I'll show you the examples, and then we'll move on. So I'm going to come back to GitHub desktop. Remember, I already cloned this and it exists on my computer, but I'm just going to delete it, right? Crazy. Get that out of here. It's gone now. When I come back here, it's going to warn me. GitHub desktop is saying, whoa, it's not where I thought it was. What did you do? You broke it, right? I could try to find it. I could just clone it again, or I could remove it. I'm just going to remove it and start from scratch, just so you see this. But typically, if this wasn't a workshop, I would just click clone again, right? But I'm going to remove it. Now it's gone, and I'm back to my normal GitHub desktop. I have a lot of repositories here. Don't be distracted by that. So I'm going to go through the whole process one more time. So I'm going to click on File, Clone Repository. And it brings up this window. Filter your repository. So I'm going to find my repository. In this case, it was called My Repo. This time it found it really quickly, but if it doesn't pop up for you, you might have to click this button to repopulate the list. But here it is for me. I'm going to choose the location where I want to put it. So in this case, I put it on the desktop, right? And I'm going to click clone. So there it is one more time. Let me show you that worked. It's back. It appears on my second screen, but it's right there. So now I have it again. I can open it up. And again, it's just a README file, just a standard text file. I'm going to open it with, this time we'll do it with TextMate, because why not? I like text editors. And, I think it's thinking. Maybe TextMate wasn't a good idea. Yeah, no, there it is. Let's just put it on a different screen. So here it is. And again, I can see it's just a standard text file. And I'm doing all of this today with just standard text files, but you can think of these could be R scripts, which is what a lot of times what we'll work with. Again, I can make another change. This time we left it at cloning is hard. And I'm going to say, this is a fun workshop again. Cloning is not so hard, right? I changed my mind about that. I'll save it. When I go back to GitHub desktop, it's going to say, hey, something changed, right? It's going to show me the lines where those things changed and what the changes were. I'm going to give an informative message. I'm going to say, I changed my mind. These are probably really bad examples of informative messages, but whatever. Commit to main and then push to origin, right? There's two ways of pushing. You can click the blue button that says push, or you can also come up here to the top and it says push origin. There's an arrow going up, like up to the cloud. I'll click on this one this time. There it goes. Okay, it did some magic. If I go back to my browser, let me go back to the repo. Let me see. I'll go to my repo. And here it is. Hello, this is a fun workshop. Cloning is not so hard, right? There are the changes. Everything's back. Everything's good. I can go back to my commit history. Look, I have 4 commits now. So I'll click on that and I can see all of the commits that I made. Right. So if I wanted to revert back to one of these, I could, or if I just wanted to see when they happened, it was 39 seconds ago, that kind of stuff. All of that information is saved in the cloud. Let's see here. Commit to main does not become clickable. Any idea why? You have to put in a message or you have to have made changes to the file. If you haven't made any changes, then there's nothing that you can commit, so it won't give you that option. And then you have to put in some type of message, otherwise it gets angry. So that probably should solve those two problems. What is the text editor program that you use to edit files? I normally use Sublime Text. You can use anything by default. I think Max will give you one called Text Edit. It's pretty ugly. I like to use Sublime Text because you can do other things with it, like you can actually run R from it, stuff like that, but that's another workshop. So yeah, I would definitely suggest you find a text editor that you like. What I'm going to show you towards the end, if we have time, is that you can actually do everything that we're doing outside of GitHub Desktop. You can do it directly from RStudio, which is, if you're working with our projects, that's the way to go, right? That's probably the easiest way to have everything in one program. Cool. I think that covers that. Let me take a look at the time. It is 8 o'clock for me. That means that we have a half hour left, correct? Okay, I think we are doing okay. So let's kind of review what this means. So we've built up a process now where we're working on a workflow, I guess you could say, of cloning, editing, changing things, committing those changes, and then pushing them up to the cloud. Now, what this means, and this is going to answer one of the previous questions, is that we can do this, right? Working on whatever. In this case, we're going to work on a repo called GitHub Practice, right? We can make changes on our computer. We can send it to the cloud. But this also means, well, hold on, there's more to this little Git imaging here, right? We keep track of these. Imagine that you're working with your advisor and he gives you comments and you go back and you change this, right? We create this awesome commit history, right? We can revert if we want to. Sorry, this is everything that I just said, but I forgot that I was going to say it. And then we can also do this from another program, another computer, excuse me. Imagine that you have a computer at work and a laptop at home or whatever, right? Since this all lives in the cloud, you can keep this same project in sync on all of your different devices. And I think that this eliminates the need for putting it on a USB device, as someone asked about before, right? Really what you would do is just use GitHub Desktop on another computer and just synchronize everything. So you can make sure that all three of these are in sync if you want to. I can get up in the morning and make changes to my document and then go to work on campus and pull in those changes and make some more changes and then go back home and then bring them back in and make sure everything's up to date. Just like you would with Google Doc or with Dropbox or whatever, it's just manual. All right, so you can still do that same thing and still keep in the same utility, I guess you could say. I was going to ask again if there were questions, but I think we hammered out all the questions, so I'll just keep moving. All right, exercise 3. Now, this is where a lot of times.
Sorry, we actually do have a new question.
Oh, let me go back. Awesome. Join event. Sorry, I have to bring it up here again. Okay. Oh, the poll has to be turned off again, I think, for me to see it. There we go. What is the main? Oh, yeah, that works too. What is the main difference between commit to main and push origin? That is a good question. So when you're committing versus pushing, I guess, is the conceptual difference here. When you're committing, it's like you're taking all of your changes and you're just staging them. You're saying, okay, you're in this little waiting room, right? You're up next, you're waiting, but you're not pushed yet. And it is kind of weird because it seems like an extra step that you might not need, but it's a way of organizing a lot of changes and keeping track of them with messages before you send everything up to the cloud, for example. So the way that this works out in my workflow typically is I usually do all of my pushing to origin at night. So I work over the course of the day and then I push at the end of the day. So I'll be working on something in the morning and I'll work on analysis and then I'm done with the analysis that I want to change and I'll commit and I'll put a message say this is the change to the analysis and it says what files or whatever. And then later on in the day, I might work on like the article where I'm writing up the prose for the analysis, and that's in a different file sometimes, right? So that one would have a different commit message and it's a different commit history because it's referring to a different file. But they're just all staged in the same area. Then I get to the end of the day and I'm like, okay, I'm done. Everything that I did over the course of the entire day, that's what I want to push up to the cloud so that it's version control. So it is kind of weird. It's like the Panama Canal, like how they go like in the middle and then like they change the water level so that it can continue. Like the commit part is like you're in that weird middle phase, right? Where it's not really in the cloud yet or anything like that. So it is kind of an odd conceptual kind of in-between stage. I hope that answers your question. Okay. Continuing. So we're going to do, this is going to be the final exercise, and I'm pretty sure that we're going to be okay on time for finishing it. And this is, I have my Grim Reaper Octocat, because this is kind of where I usually lose my students. So I'm going to try to be extra careful and not lose you here. This is what we're going to do. I'm going to give you the actual steps that we're going to do right now beforehand and tell you what we're going to do. I don't want you to do it yet. I just want you to know. And then I'm going to give you a conceptual overview of what that looks like with pictures. And then I will actually do it. And then I'll have you guys do it. All right. So this one's a little bit more difficult, but still not too bad. And essentially all we're doing is adding one more step to the process that you've already done. So we're going to talk more about collaborating on projects by using forks. Okay. What you're going to do first is fork a repo called GitHub Practice that I've created for you. You'll learn that forking just means like making a copy in the cloud. Then you're going to clone this new repo onto your desktop. You're going to open a README file or any file in this project. You're going to edit. You're going to commit changes. You're going to push the changes to your copy on GitHub. And then you're going to submit a pull request to actually try to change it on my computer or my version of it. All right. So this is kind of weird. Conceptually, let's see if we can break down what this means. So imagine that we're going to have a repo in the cloud called GitHub Practice, which we're going to have. This is foreshadowing, right? And all of these little computers represent you guys in the crowd, okay? So what I'm going to ask you to do is to fork a copy of GitHub Practice, which means all of you on your computers or on your GitHub accounts will have a copy of GitHub Practice. And each one of these little copies is individual to you. It's now yours. It's connected to mine conceptually, but if you change your version of it, it does not change my version of it. Okay, and this is how program development works a lot of the times. Okay, so then what you're going to do is individually, you're going to make changes on your computer. You're going to push it to your version on the cloud, and then you are going to send that to me. Okay, conceptually, that's how this is going to work. And this is actually, at first, it seems kind of crazy. It's actually a lot of fun once it really works. And actually, there's an AutoCAD GIF for this one as well. I was quite impressed. I thought that was pretty cool. Okay, so this is what it looks like. All right, I'm going back here. I'm going to go to my repos just to show you that this exists. I won't actually be able to do it this way, but just to show you that it exists. I will find, oh, here it is, GitHub Practice. This is a repo that exists on my GitHub account. And I'm actually going to put this link into the chat because I'm going to have you guys use the same one. You could search for it as well, but there you go. You have it right there. And as you can see, this is a project, right? It says use this repo for practice, but I've designed it in a way so that it's similar to what most of my projects look like for doing research, right? I have data. If you go in here, it's just a CSV file. It's the MT-CARS data set that comes with R. So nothing special. Docs. There's an R Markdown file here. You can play with that later on. We won't see that today. Figs, I haven't saved anything here, but this is where you would have, your figures saved. Scripts, I have an R script, right? And you'll notice that every single one of these folders has a README file. And usually in those README files, I explain like what that directory is for. Slides, so this would create an R Markdown presentation, blah, blah, blah. There's lots of stuff here, but I'm actually just going to have you fork this and then edit the README file. So what does it mean to fork? Like I said before, it means you're going to make your own copy of it. So there's a button up here and it says fork, and all you have to do is actually click this button and you can fork it. Now, since this is my own repo, I can't actually fork it, so I can't show you that. So what I'm going to do is I'm just going to search for a repo and I'll fork that one. One that I use a lot, or a program that I use a lot, is CyclePy. This is actually, I don't think I can search for it from here. This is a program. Oh no, it was from here. This is a program of Python, a bunch of Python code actually, not Python, CyclePy. That I use to present stimuli, right, for experiments, which I'm sure some of you have heard of it or maybe used it before. And it's open source and all of the code lives on GitHub, right? So I'm going to go to their repo, and this is the source code for CyclePy, which is pretty crazy. There's lots of files here. There's a lot going on. There's a lot of issues and pull requests and all kinds of fun stuff here. Look at the commit history. There's been 15,000 commits. Obviously, this is a very active project. So I'm going to fork it. Right? Who am I? I'm gonna give me your source code, CyclePy. I'm gonna play with it, right? I'm gonna fork it to my username, right? It's forking. It might take a couple seconds. I don't know exactly how big it is, but it's doing this. You guys will see the same thing. And now, if you look up here, it's my username and CyclePy. I now have the source code for CyclePy, and it tells me where I forked it from. All right, cool. That's the forking aspect of it. Now I'm gonna show you. We're gonna do the clone. What is this? Okay, I don't need this anymore. I don't need this anymore, so let me make sure I'm up to date. I'm going to go back into GitHub Desktop, right? And now I'm going to clone this repo that I just forked. Now you guys are going to do that with GitHub Practice. I'm going to do it with CyclePy just because I can't do it with GitHub Practice. So I'll go up here and I'll say File, Clone Repository. And again, I have to search for it. Now, since I just forked it, it should be available to me. So I'll search PsychoPy. And PsychoPy templates workshop, I probably have to repopulate this because it's a new one. And there it is right there. I do a lot of stuff in PsychoPy, as you can see. I have other workshops and stuff. So JD Casillas PsychoPy. All right, this is the one I want. I'm going to choose my path. I want to put it on the desktop again, and I will say clone. This one might take a little bit longer because, you know, it's bigger. It's doing it, but now I have a folder on my desktop called PsychoPy. It's still cloning, but I moved it. So there you go, moving deltas, it's changing things. Okay. Are you planning to, okay, you're probably going to get this message saying, how are you planning to use this? Just go ahead and click cancel. If you want, you can read that later and worry about it. But for now, just click cancel, right? And now I have it on my computer. I can open up the project. So I'll open up PsychoPy and see all of these wonderful files that they have. And I could just pick one at random, authors, for example, and I'm going to open it up. I probably don't need to mess with this, but whatever. I'm going to open it up in Sublime Text, and I'll go, okay, here it is. This is all this interesting stuff, all these people that worked on it. I'm not going to edit this too much. I'm just going to add a space, add a new line, and save it just so that you can see that it changes in GitHub Desktop. All right, it's telling me the author's file was changed, and this is the specific change that was made to it. So I'm going to go ahead and I'll say showing PsychoPy stuff. I'm really bad at giving you guys examples of informative commit messages. Please don't follow my example here. I spelled something wrong, so I could whatever. Commit to release. No, I don't want to do that. I want to. Oh, that's the branch. Okay, that's fine. Yeah, sure. Whatever. Commit. Push to origin. So this is just going to go to my computer here. Good. Okay. Click this. Okay. And now it's telling me I've committed it. I look at it. It's telling me this commit is one commit ahead of the real PsychoPy. So it's telling me we're not on the same track. Our versions are different. Now at this point, what I would want to do, imagine I can even see it. Where's the author's file? Right here, I can see showing PsychoPy stuff 13 seconds ago. Now imagine that I wanted to send this to the actual PsychoPy people. I do not. This is kind of scaring me because I don't want to accidentally send it, but I won't. I would click here on this button that says pull request, right? Pull request right here. And I would say new pull request. Now I'm going to just stop check and click this and then I'll stop it after that, right? It'll tell me if it's able to merge, what I want to do, what changed. And then I would click this button to create the pull request and that would send it to the PsychoPy people and then they could look at it and decide if they want to use it or not. I'm not going to do that. I just wanted to conceptually show you how this works. So let me actually run away. Don't do it. Go away. Let me just go back home. Okay. So that is conceptually how that works. I will stop at that and I have to make sure I remember to delete all that afterwards. Now, let me come back here to the walkthrough. That was conceptually how we're going to do that. Here again are the instructions, right? So again, you're going to fork the GitHub practice repo, low stakes. You can mess this one up. Nobody cares. Clone it to your computers, edit any of the README files. It doesn't matter. Just one, save that, commit the changes and push changes to origin on GitHub and then submit a pull request. And at that point, I am going to show you, let me escape out of this. On my computer, I'll go to GitHub practice. I'm going to show you as the pull requests come in, right? What this means conceptually and how this works. So go ahead and start doing that now. I will open up Slido for questions as they come in, because usually this is where the questions will start. And we will work through this. And how am I doing on time? Okay, we're at 15 minutes. We're okay. All right. Will you be showing how to use R Markdown and Git on Friday's session? I will briefly talk about it. But obviously there might be people there that didn't do the Git stuff, so it won't be a major point, but I will point out how to do that. Yeah, it's quite simple. I usually work with Word files and SPSS files, so is this still smart to GitHub? You still certainly can use GitHub for that. I mean, it won't give you much benefit on the Word files. It will keep you up to date with them. The SPSS files, I'm not really sure what the internals of those look like, but I would imagine that it probably tracks something there too. So I think that it would certainly be worth trying, and then you can decide if it's worth it for your workflow. It may or may not be. I'm honestly not sure because I don't work with SPSS too much. So if I go back here, let me take a look at this and see if there's any forks coming in. See some forks. Yeah, 14 forks. So 14 of you have forked the repo, which is fantastic. I can even see who. Look at that. I don't think I have any repos with that many forks. So that's kind of cool. questions? I'm still doing okay here. Oh, I am blocking the steps. So let me move this in case you can't see it. I'm stuck on step 2, clone the repo to your computer. Okay, so at this point, if you've already successfully done the fork, all you need to do is open up GitHub Desktop and then click on File, Clone Repo, and then search for GitHub Practice. So just like exercise 2, it's the same process. You're just looking for a different repo this time. And hopefully that should take care of that for you. And keep checking back and forth to see if we start getting pull requests coming in. Awesome, 7 pull requests, 22 forks. All right, it's working. We're doing it. I'm not gonna lie, I usually have more issues at this stage when I teach this. So this is good. You guys are fast learners. I'll say, what time is it? 8:17. I'll say we'll give it another maybe 2 minutes. And then I will show you the pull request from my side. Does removing this practice repo, which is forked, follow the same process as you showed us before? Yes, exactly. So you would just go to the settings of that repo of your forked copy, and then go down to the danger zone and delete it just like you did before. And then you could find the clone copy on your computer, the local copy, and just delete that as well. It's exactly the same. Here. 9 pull requests. Awesome. 23 forks. In a perfect world, I would wait until the pull request matched the number of forks, but since we're getting close to the end, I probably will only wait 2 more minutes just to double check.
Can I ask a question then, as we're waiting?
Absolutely.
How do I know if my pull request has been like, so I did like pull request, how do I know if actually you accepted it in a sense?
You so you'll get notifications from GitHub typically once I actually accept it. So let me show you what that looks like from my end. Now I have 12 pull requests. Fantastic. So I'll just go in here and I can look through and I can see all of these. I will see what your messages were, which is kind of cool. Some of them just the default update readme, added test, added to readme, right? So I'm going to find yours, which is right here. And I can look at what you did, right? It's going to say if I'm able to merge it or not. And I can actually look at what files were changed. And I can see the changes. Use this repo here, messing this up, right? So this is your change right here. And at this point, I'll go back. We can have a conversation. Let's assume that you did this and I don't like it, right? I can come here and I can make a comment. No, change that. You didn't mess it up, whatever. We can go back and forth and you can actually change it more and it'll just update the pull request. Or let's assume that I like it. And in this case, I like it. It seems like a worthwhile change. I'll say merge pull request, confirm merge. All right, it took it in. At some point, you're going to get an email probably saying it did. And now if I go back to my copy, I can see that you added to readme. And right here, I can see messing this up. I can see your change on my version, right? And then at this point, I could go back to my local copy, which I don't have on my computer actually. And then I could update my copy on my computer. So it's not just in the cloud. All right, so it's this nice communication process where we can go back and forth. And this is actually really useful when you're working on an article, for example. So to put this into to context for those of us that do research, imagine that you're working on an article and your contribution to this article is doing the analysis section, right? And someone else is doing the conclusion or whatever. Then you can work on those files individually. You can send in this pull request to the person you're collaborating with and they can look at it and they can go, okay, cool. Maybe you can make some changes here, or you forgot to add in this, or there's a typo here, right? You can go back and forth and have a conversation about it. And then you can pull into main, right, the changes that they made when you're finished. Or the same way I work like this with my students when we're working on dissertation chapters and stuff like that, where it's a conversation for a while on the pull request. And then once it's good to go, we, send it, merge it in, and everything's done. Let me just update this 13. So yeah, some more pull requests coming in. I'll take a look at a couple more, but I guess we probably don't have time to just bring them all in. But yeah, all kinds of, if you can see your pull request here, if you see your username, so you know that I did get it. I'm not ignoring all of you. Just come in and we can see what kind of changes were made. Tutorial, cool stuff. Checking for the conflicting file. Okay, the file's different now. And that's more or less how that works. Now, I think, let me come back here. And I think there's some other ideas I wanted to talk about. Yeah, key ideas. So again, we can fork other people's repositories, right? We can then use our same process that we did before, where we clone the forked copy. We can make changes. We do our typical edit, commit, push that we learned in exercise 1 and practice in exercise 2. We can then send our modifications to the original repo if we want to, using pull requests. So that's kind of the new conceptual idea here, forking in pull requests. And that is, I don't know, I want to say like 80% of what my workflow looks like when I use GitHub. That's 80% of what I do. Every now and then there are some more involved things that you'll learn as you go along. But if you followed along for these 3 exercises, obviously you have to practice them so that it becomes second nature, but you are operational, and this is the majority of what you would do on GitHub. Tips: learn from other people by forking their projects. I think this is absolutely 100% the best way to learn, especially in R and just statistics stuff. Like maybe you read a cool article where they did this really awesome analysis. You can, if their project is open source and they are into open science, you can fork their projects and then you can play with it. You can mess with their data. You can do the exact same thing. You can see exactly how they did everything. You can look at the commit history and look at how they changed their analysis, that kind of stuff. I would also suggest doing pull requests and contributing to other people's projects. If you're working in a collaborative group, maybe it's not as fulfilling, you're just doing normal work that you have to do, but it's also a great way to get involved with open source, I don't know, just other like applications and stuff. One of the first pull requests I ever did was for the Advanced R book by Hadley Wickham, where I just corrected a typo. And it seems really, really silly now. I was a grad student a long time ago. And in hindsight, it was super fulfilling. I felt like, oh my gosh, it worked. I did this. And then there was an acknowledgement when the book came out, which was super cool. I went and bought it just so I could like, hey, look, that's my GitHub username. So I would definitely recommend trying to get involved in that. At this stage, you're probably like, okay, I've been using Git for 2 hours. What could I possibly contribute to an open source project? You would actually be really surprised. Most developers are extremely happy to have people just work on documentation, right? Just go through the READMEs and look for typos, and it's just an opportunity to practice the whole fork, clone, edit, pull request, the whole process. And it is extremely fulfilling if you're I don't know, nerdy like me. And then also, I've said this several times, if you get stuck or you make a mistake at any step, you can always burn down the house and start over. And I tell you, I do this a lot. It's pretty common. Don't feel bad. You want to just make sure that you have another copy, right? Just in case, right? But practice makes perfect, right? That's how you get the hang of it. I guess at this point, it's a good idea to look and see if there are more questions. Yes, there are. If you update your GitHub practice repo, we already talked about that. How can I see those changes on my fork repo? So if I update mine, how can you see the changes on the one that you forked in? Okay, that's a good question. If you're doing this from GitHub in the browser, you would just create another pull request, but you would change the main and the origin, the destination, right? So normally when you do it, you would go from the forked copy to main, but you can do, it's a drop-down menu, you can just switch it. So you're going the opposite direction and you can just load in the changes that way. There are more technical, more efficient ways to do it with the command line, but that's one way to do it with the browser. Is the pull request, about a specific file or the full project? It's the full project, everything that's under version control in the project. But usually you would want to just work with small changes at a time or commits at a time. But yeah, it's the full project, whatever's in the repo. I changed the file, but don't remember how the pull request works. Yeah, let me just show you the screen again. So whenever you're in one, you would just click. I probably have to go to CyclePy again. Yeah, my version of CyclePy. I can show you this really quickly just to bring it up again. So here's CyclePy. There's a button right here that says pull requests. I would just click that button and then new pull requests. That's where that was. What happens if you accept several pull requests from the same section? Does it change the file? The last one that merge everything? So this is a great question. So when you're working with something like this, where I just did this with 23 different forks or whatever, this would create chaos if you guys are all changing the same file. right? Because Git would be like, whoa, which one do I use? What's going on here? Like what you're telling me to change it to from that computer isn't the same as what I have right now. And those are what are called merge conflicts. This has all been sunshine and rainbows, and I haven't talked about famous merge conflicts. In those cases, you would have to actually go through and make decisions about how those changes would be implemented into your branch because it's already different from the one that's coming in the pull request. You typically won't have to deal with that unless you're working on a huge collaborative project where a lot of people are working on the same files at the same time. And I have information about the strategies for dealing with that, but we don't have time to talk about it today. But I'm going to give you a tip in just a second. What are some of the advanced features of GitHub? The most exciting things, the advanced features in my book, have to deal with how you can use the R&D files for repositories and using those in an ecosystem of websites. So to give you an example, this is my website. It's shameless self-promotion right here. This is my website about this and that. This is just a GitHub repo. And every repo that lives on my computer, let me go back to here, every repo that lives on my computer, on my GitHub account, in my repositories, there's 112 of them, can potentially be websites that I show from my website, right? It's just connected to the same account. So imagine, you guys probably already noticed the URL, but I can just add in here the name of the repo. For example, GitHub practice has readmes, but it doesn't, GitHub workshop, right? Let me just go to this one so you can see the readme. So I just added GitHub workshop, the name of the repo, to my my website. I go here and you can actually see it goes to the presentation, right? Which is just a repo, it lives in the repo. I do this literally everything that I do in life is a repo now. Like my teaching, like all of the classes that I teach, they're just repos. And I have a folder for slides, a folder for assignments, that kind of stuff. And it's all associated with my account. Therefore, it's all accessible to me for like conference presentations and stuff. So for the academic, it's really nice to have everything in the same ecosystem. It works and plays really nicely with R. And then like if I go to a conference now, most of the time, you know, there's a computer there. I don't even bring my computer. I just go in and go to the website for my presentation. I can do, and it's nice and easy. It can be a PDF or it could be a PowerPoint. It could be an R Markdown, HTML presentation. It doesn't matter. That's the thing that I get the most excited about when it comes to GitHub, but there are other things as well. Yeah, that probably didn't cover everything that it does, but that's a good amount. Let's see. So let's do a little bit of review before we finish up here. So some metaphors and terminology. We did talk about a lot of odd specific terminology. Here's the list. I'm not giving definitions, but I do see there's a hand. Shidi, do you want to ask a question?
Yes, but I didn't want to interrupt while if you want to do the review.
It doesn't matter. If you prefer to ask it now or if you prefer to wait, either is fine.
So it relates to the question that was beforehand. I'm sorry that I don't know if it's the fact that there's several of us using the admin account together, so I can figure out how to put the question there. Beforehand, someone asked about like reforking. If you, for example, updated and I want to fork your folder again, what happens then to all the changes that I made on my fork? Are they just gonna go away? Is it gonna merge them? What happens if they're incompatible?
Great, that's a good question. So in most situations, we'll assume, like, let's say that you're working on your forked copy, right? And you're working on a certain R script, for example. And then somebody else on another copy is working on writing up the article, right? So those versions are different. What you would do is you would just pull in those changes to your version, right? And in most, not in most cases, in this case, let's assume that they're different files, then it doesn't matter. It just incorporates those changes into your version and you're good to go. Now let's assume, okay, what happens if you're working on the same file and you have different changes, so they're just mixed up versions? Then that would be a case where you have a merge conflict and you have to actually go through and you have to decide how you want it to merge into yours. You have to decide what changes you want. And GitHub gives you an interface to go through and look at those. Right, and you go through one by one and you adjust them. Those aren't as fun. Sometimes they can be kind of scary at first, but usually they're not that bad. Or I haven't had too many problems with them as you go along. But I would say you won't deal with those as much at first. Those are more advanced cases, I think.
Okay, but the goal is always it's going to try to merge rather than overwrite.
Yeah, and it will always tell you, and it'll always, if there is a conflict, it'll always tell you like where the conflict is and how you have to resolve it. Yeah, that would be GitHub Workshop Part 2 to go through like create merge conflicts and deal how to fix them and stuff like that. It's an important concept. So as I was saying, there's a lot of metaphors and terminology here that's really weird. As I said before, I think this is the main barrier to entry when you first get started, right? What is a repo? It's just a project. committing, cloning, pushing, pulling, forking, pull requests. It's really odd, right? But once you've used it for a while, it's pretty standard. It's not that big deal. And there's more. Now, obviously, I'm giving you like the overview and kind of like the easy stuff. There's definitely more stuff involved with it. This has been kind of like, this is mine. I threw you into the deep end, right? And I think nobody drowned. I don't think anyone drowned today, but you probably get the feel that there is some of this that can get a little bit more complicated, but it's not too bad. It's fun to learn. So next steps, if you were to continue in your Git journey, I would recommend exploring branches. And that's how you do, that's like the way to avoid merge conflicts, but yeah, branches, merge conflicts, and then slowly working towards the command line if you are brave and you want to, but definitely it's not necessary. Okay, that is it for what I had for you. I will point out some tips and tricks. If you continue, so the slide number here, it says there's only 49 slides. But that's a lie. I changed it because I didn't want to scare you with like 100 slides. But if you just keep going, there's a lot of advanced tips about projects, about other ways of naming conventions, other stuff with using R. So I would definitely encourage you to go through that on your own if you are interested. As I said before, this presentation is just a GitHub repo that lives online. So you could come here, you can fork this if you want to, you could create issues and ask questions. I'm definitely available to help out with questions or anything that you might want to ask. And thank you very much for your attention.
Thank you so much, Joseph. Guess we should use the virtual reactions, but that was so clear and really great. There's a couple of things in the Slido question box, but I think you've already answered them. Like if we need more resources or questions, how can people reach out? I remind people that we also have the kind of conference booklet, and I think, Joseph, your details are in there, like your Twitter handle, email, and
absolutely.
So yeah. And yeah, just some comments saying that it's been really useful to say, like, people were nervous, and this was really great. I think that's it from all of us. So it just remains me to thank you and say, like, we're looking forward to Friday morning with more art mocked on with you. For people joining us for the next session, I think that's at 2:30 and it has a different Zoom link. So just make sure you use your program schedule and you click on the link again. I think that's it, unless Sherry wants to remind me of anything.